Linear inequality equations. These equations, instead of having an equal sign, will have a less than, greater than, less than or equal to, or greater than or equal to sign. But they're still solved the same way as if it were an equal sign. The only difference is this special note right here. If you multiply or divide both sides of the equation by a negative number, the inequality sign will reverse direction. It has nothing to do with the answer, it's all about the process. If you multiply or divide both sides by a negative number. Keep that in mind. Now we're also going to graph these on a number line. So now if you see a less than or greater than, that means it's not included. The number that's involved in the answer is not included in the final answer. You can use an open circle or you can use parentheses. Now if it's less than or equal to or greater than or equal to, you'll use a closed circle because the closed circle represents that number is included in the answer. You can also use brackets. So we're going to do a few examples. So let's solve this question right here. Now pretend this is an equal sign. So we're going to do the exact same steps. The whole goal to solve is to get the x all by itself on one side of the inequality sign. So what that means is we're going to eliminate that minus 6 by thinking the opposite of a minus 6. The opposite of a minus 6 is a plus 6. And once you do to one side, you do to the other. So minus 6 plus 6 becomes 0, which just means I'm going to cancel those out, and it leaves an x. Negative 11 plus 6 is negative 5. Now, since I didn't multiply or divide by a negative number, I'm going to keep the inequality sign as it is. I'm going to graph it, and you can do more numbers than what I'm going to do, but this is basically negative 3, negative 4, negative 5. We're on the left side of the 0 on the number line, and negative 6. So negative 5, since it's greater than or equal to, that means it's included. We can use either a closed circle or a bracket. I'm going to use a bracket. Notice it's greater than. I want the x on the right side. What that means is every number bigger than or equal to negative 5 will be in our solution set. So that means I'm going to shade to the right of negative 5 because all those numbers are bigger. I'm going to draw an arrow to represent that, which that arrow means it goes forever to the right. I'm going to put a bracket here on that negative 5. Now I easily could have used the open circle, but I'm going to use a bracket. Now let's go to this problem. The whole goal once again is to isolate x on one side of the inequality sign. In this case the less than sign. So to get rid of the negative 2 that's being multiplied, because that is multiplication, if you want to put a dot there, I'm going to divide because the opposite of multiplication is division. It's actually the inverse, but we'll just say opposite. These negative 2's cancel out, leaving the x, and 14 divided by negative 2 is negative 7. Now if I leave the less than, that means that if I were to take any number less than negative 7 and substitute for x, it's going to check out. So let's take like negative 8. Let's just draw a number line. A number less than negative 7 is negative 8. If I substitute the negative 8 into the x, I'd be taking negative 2 times negative 8, which is a positive 16. Is 16 less than 14? No. 16 is greater than 14. That's a false statement. If I were to take a number, say greater than negative 7, which is negative 6, and substitute it, I'll have negative 2 times negative 6, which is 12. Is 12 less than 14? Yes. What that means is, in order for us to get a true statement, this less than has to reverse direction to greater than. And since it's not included, I'm going to put a parentheses, and I'm going to shade to the right. So what's going on here is I'm divided by a negative number, which meant that I had to switch the inequality sign. And the reason why I had to use parentheses and not a bracket, because if I substitute the negative 7, I'll get negative 2 times negative 7, which is a positive 14, and 14 is not less than 14. It's equal to it, so that's why I have to use a parentheses to represent that it's not part of the solution set. Now I'm going to draw these. I'm going to solve these like I normally would, and I'm going to graph them. So in this problem, I need to isolate the x by eliminating the negative 3 and the 11. I'm going to eliminate the negative 11, or the 11, because it's all by itself. It doesn't have a variable. I'm going to do the opposite, which is subtract. We get negative 3x on the left side. I don't switch because I didn't multiply or divide by negative. I'm going to add those when we get negative 24. Our next step is the divide, because that's multiplication. But as soon as I do that division, I'm changing the direction. And x is greater than or equal to positive 8. I might come back and graph these later. On this problem, I'm going to distribute to eliminate the parentheses. So I get negative 4x, and then negative 4 times the positive 1 is in negative 4. Now on these, I like to keep the x on the left side. It makes the graphing a little bit easier to do. So that's what I'm going to do. I'm going to always have the x on the left side, which means, and I always work with the x's first, which means I'm going to add the 4x to both sides, because I want to eliminate it from the right side and move it to the left side. And then I'm going to combine like terms. Negative 6x plus 4x is negative 2x. Then I'm going to bring everything else down. I don't switch unless I multiply or divide by negative. I'm going to eliminate the negative 3 by adding 3, because I want the x by itself, which means we're going to end up with negative 2x on the left side greater than negative 1. Once again, I have it multiplied divided by negative until now, because to eliminate the negative 2 being multiplied, I got to divide. And as soon as I do that, I'm reversing direction and end up with x is less than 1/2. So just be aware, this is what's going to happen. All the same steps as you have seen with linear equations. They're all the same unless you multiply or divide by a negative number. And now we're going to try a slightly different problem, one that you may or may not have seen. I call this a double-sided equation. It's actually two equations in one. If I were to cover that up, you would have that equation. If I were to cover up that side, you would see that equation. But no matter how I look at it, say I look at this. I want to get the x by itself. The way I get the x by itself is I subtract the 1. Once you do the one side, and do the other. Now if it were this, I would still subtract the 1, and once you do the one side, you do the other. So the rule is, this way I like to say it, once you do the one side, do the all three. And so what happens then is, in the middle, the 1's cancel because 1 minus 1 is 0, and 0 is what we want, because x plus 0 is x. I had that multiply divide, so I'm going to keep the signs as they are. Then I'm just going to work out the other two sides. Negative 4 minus 1 is negative 5. 8 minus 1 is 7. I'm going to graph this one, and notice, see this x is what this is saying is it's between negative 5 and 7. The negative 5 is not included, but the 7 is, because of the equal sign underneath the less than. When I draw the graph, I'm just going to put a negative 5 and say like a 0, and then like a 7. Now if you notice where the x is, it's between negative 5 and 7. That means I'm going to shade in between those. Since the negative 5 is not included, I'm going to use parentheses. Since the 7 is included, I'm using a bracket. So to summarize what I'm doing on the graph, it's a preview to interval notation. Interval notation just means we're going to use parentheses and brackets to represent the solution set. Parentheses means not included, brackets mean included. I'm going to use an abstract example to explain the possibilities that you will have. If you see parentheses A comma B parentheses, what the A comma B means, it means every number from A to B. So the comma just means between A to B. Now, since I have parentheses, that means that A or B, neither one are included. Now look at this one, with the bracket around the A and around the B, that means that both A and B are included. On this one, the parentheses around the A and the brackets around the B, that means that A is not included, but B is. And with the bracket around the A, parentheses around the B, A is included, B isn't. So this is just a general notation for interval notation. Brackets and parentheses. A comma B. Parentheses mean not included. Brackets mean included. Parentheses not. Brackets are. Now another type of notation is set builder notation. For this class, we're going to use these set braces. We're always going to use X. I mean, we may use Y or N if the problem has it, but for the most part, we're going to use X. This little line means such that. So when I read this, this is read as X such that, and then we're going to give x some property. And we're going to use this example, these linear inequalities, to explain what's going on. So we're going to solve x plus 3 greater than 7. We're going to graph it, and we're going to express it in interval notation and set builder notation. So to graph it, we're going to isolate the x by subtracting 3. We get x is greater than 4. Now I'm going to graph it. Now, I'm going to put a 4. Since the 4 is not included, parentheses, and I'm going to shade to the right. This really helps you with the interval notation, because all it is, with the interval notation, it means that we're going to use the bracket, or the parentheses I should say, parentheses means not included, and the 4. Now this arrow is going to the right. What that means is it's going forever and ever and ever. The way we show forever and ever and ever is with infinity. It's a sideways 8. It goes forever and ever and ever. So we're going to use that down here in our interval notation. So what this means is it's 4 to infinity. 4 and every number greater than 4. 4 is not included though. Since we don't know how far it goes, we can't include it because it never stops. We're going to use the parentheses always around the infinity. Now this is the interval notation. Now for set builder is actually a little bit easier. Because our set builder is just braces, variable, call it x, a line for such that, and then we're going to just put this answer as our property, x greater than 4, and close it off with the second part of set braces. That's called set builder notation. In other classes you might have a little bit more, but for this class we're just going to write it like this. So let's do a few more. Let's use the ones we've been doing. I want to use the last two that we did. Let's look at this one. Now, with interval notation, what that would be is, notice the negative 5 has a parentheses around it, and 7 has a bracket. Now I just use a comma between them. This represents every number between negative 5 and 7. Negative 5 not included, 7 is included. Let's look at this one over here. X less than 1/2. Since we didn't draw the graph, let's just see if we can imagine it in our heads. If I were to ask you to represent this in interval notation, how far left would it go? Well, less than means left. It's going to go forever and ever and ever towards infinity, but to the left on a number line is negative, so we're going to use negative infinity. And then it goes to the right at 1/2 and stops. It doesn't actually quite get there, so we're going to use parentheses to represent that. Now if you wanted to graph that, x less than 1/2, here's how it would look. We will plot 1/2, put parentheses around it, because the 1/2 isn't included. We will shade to the left, because less than is left. Put an arrow there. Now with set builder notation, braces x such that x is less than 1/2, and that's called set builder notation. And that's it.